Okay, so number 16a, you can't just plug in 9 because it turns out that you end up with 0 over 0 in that problem, which is undefined. So instead, we try to manipulate the function to come up with a version of it where you can plug in 9. So let's see. The numerator, I'll just leave the same for now. The denominator, I'm going to factor out an x and get x minus 9. So there it's pretty obvious. I can't just plug in 9, right? Because then I get 0 in the denominator. So one trick that we could do to come up with a function that looks an awful lot like this one, but is slightly different, the only difference is it'll have a hole, is if I multiply by this, the conjugate of the numerator. So the trick here is to get rid of the square root in the numerator. So if I do that, then I'm going to get this, limit as x goes to 9. And then the top, root x minus 3 times root x plus 3, that's going to be x plus 3 root x minus 3 root x, and then minus 9 over x parentheses x minus 9 parentheses root x plus 3. And I'm going to leave the denominator factored because the goal is almost always to try and cancel stuff. So in this case, well, this function has a hole when x equals 9. And if I cross these off, well, then I've created an equivalent function. The only difference is that hole's filled in at 9. So now I can write this, limit as x goes to 9 of 1 over x root x plus 3. And at this point, I'm allowed to plug in 9 into that. So that becomes 1 over 9 parentheses root 9 plus 3, which is 3 plus 3. So it's 1 over 9 times 6, 1 over 54. So there's that limit. In part B, this one's a little bit trickier. So let's take a look at how this one works. I'm going to do it in a somewhat roundabout way here. 3 sine 4x over sine 3x. Okay. Well, let me just move that 3 out in front just to start so that we don't have to deal with it at all for now. Sine 4x over sine 3x. Okay, if I multiply this by 4x over 4x, then what I'm going to get is this, 3 limit x goes to 0. I'm going to put the 4x out in front here over sine 3x. That part I'm not going to worry about for now. But then I'm left with times sine 4x over 4x. And if you remember, we've done a couple problems at this point where if you have limit as x goes to 0 of sine some x, like let's just do 6x over 6x, if these guys are the same, this goes to 1. So this part right here goes to 1. So now I'm left with this, 3 lim x goes to 0, 4x over sine 3x. Okay, so let's try something else. What can I do here? Let's do this. If I multiplied the denominator by 3 over 3, just the bottom, right? Then, sorry, 3x over 3x. Then I can write this way. 3 lim x goes to 0, 4x on top over 3x sine 3x over 3x. Well, this part right here now turns into 1. So now I'm left with this. That turns into 1. So I've got 3 times the limit as x goes to 0 of 4x over 3x. Well, that's just 4 over 3. So this turns into 3 times 4 over 3, which turns into 4. Okay, that's a lot of kind of subtle algebraic manipulation, but it does work. So hope that helps.